was to show that this is equal to something else, right? That was the question, right? And so, I mean, there are several ways you can do this question. The easiest way is to write it like this. All right, is to write it like this and then put brackets around this, right? Now what you have is a plus b raised to the power 4. Now you can use the binomial expansion. So I'm not going to do it, but all right, you should use the binomial expansion for a plus b raised to the power 4. So this is your a, and this is your b. All right, and when you do this expansion, you will get 5 terms. All right, you will get 5 terms when you expand a plus b raised to 4. Right, and one of the 5 terms is 0 because all right. Now, one of the 5 terms is something like this. Is 4 times the sum of one of the 5 terms is this, right? And you need to show that this term is equal to 0. Several of you just said that this is 0 without actually showing it. You know, in mathematics, you can't just say x equal to y. You need to prove why x is equal to y, right? It's not good enough to say that something is equal to something. So this term is 0 is 0 because the reason that this is 0 is because the sum of xi minus x bar, right? This you can write as the sum of xi minus the sum of x bar. Now x bar is a constant with respect to I, so this becomes, this guy you can write as n times x bar, and this also n times x bar. So hence this is 0. So this is the argument you should give. Now, like many of you did this, but some of you did not give this explanation, and you lost marks for that, right? Because you did not explain why this guy is 0, right? All right, guys. So that's feedback, and one other thing about quiz 2, which I found very odd, is the following. So this is also on quiz 2. Sorry, quiz, my spelling is wrong. Quiz 2 feedback. Some of you, I noted that some of you said that x bar, remember x bar is a sample mean. This is the sample sample mean. And mu is the population mean. All right? And some of you said that these two are equal, which I never taught in this class. Did I ever teach you that x bar is equal to mu? Right? I mean, x bar is because the population is usually a very big number. Like it could be like the all men in the UK, which are in millions. So you can't access the population. Right? Like if you are interested in the heights of all men in the UK, that's impossible to estimate, impossible to access. So the population mean, you will never know what it is, right? The sample mean is you select a sample, say 100 men, and measure their heights, right? And take the mean of that. That is sample mean, denoted by x bar. So these two are never equal. They are never equal, right? X bar and mu can never be equal, right? Okay? So it is plain wrong to say that x bar is equal to mu, right? Okay. The reason that they can never be equal is because the population is usually something not accessible, right? So they can never be equal. So that's quiz 1, quiz 2. Right. The other thing I want to announce is I looked at. Thank you for completing the week 3 feedback, which I put online. I don't know whether you noticed on the course website. I have put all of your comments. You can read them yourself. You should go to the course website, and I'm happy that almost all the comments are very positive. Thank you for that. I mean, I will continue to support you 24/7 in any way possible. I think some of the negative comments were the following, that the support classes I do agree with this comment that the support classes are too big. I mean, I said to the department that, I mean, currently we only have 5 groups, right, which is not enough at all. I wanted more groups, like 8 or 9 groups, so that you have smaller classes. But the department said they don't have the resources. Although I told them that I'm prepared to take all the 9 classes myself. And still they said that they don't have resources, which I find difficult to understand, right? There was a problem with the project. Yeah, the projector in Roscoe Theatre A has a problem. I reported this to the media services, and hopefully they will fix it before next week. And I know it gives a shadow. When I write things, there's a shadow falling on top of it. I don't know whether you noticed that. Yeah, so I'll try to fix it. I mean, I hopefully they will fix it before next week, right? I'll let you know. And some of you said the quizzes. I mean, by the way, the purpose of the quizzes is to do something slightly of higher standard than what we actually learn in the course, right? They are based on what we learn in the course, but they are of higher level than what you actually do. Right, that the kind of examples I do during the lectures are very simple examples, as you know, as you've seen. But the quizzes are a little bit more higher level, because the reason I do that is because I want you to, practice some harder questions by yourself, right? So that when you get to the exam, you feel more confident about it, right? Okay, so quizzes are of higher level. I mean, and also, as you know, they are assessed. The quizzes are assessed every week, right? And I want you to practice on some questions that are of higher level than the examples that I do during the class, during the lectures. And some of you also said that you would like more examples or explanations. And I will try to do more examples during the rest of the course. And so far I've been doing just 2 examples per topic. Maybe I will try to do more examples in the future. Okay. And finally, the pace. Some of you said the pace is too slow, and some of you said is okay. Some of you said is quick. So I'm kind of confused about. I'm kind of confused about the pace, but I will try to kind of increase the pace a little bit, if that is okay with you. I hope you don't get confused if I increase the speed. But if you do, my support is available to all of you 24/7, right? And please do feel free to Zoom me. I'm disappointed again the number of people Zooming me. Don't be afraid, Okay. All right, guys. So these are the comments from the week 3 feedback. All right. Now the next thing I'm going to talk about is what I covered on Tuesday this week. I'm just going to review the stuff I did on Tuesday. All right. So on Tuesday this week, I talked about the properties of sum. Can you see this? Yeah. These are some properties of sum, and as I said, some of these properties you need to remember these properties, guys. Especially in quiz 2, some of you made mistakes because you did not know these properties. So it's important that you do know these properties, right? And these are properties of the product. This is the definition of the product, and these are some properties of the product. I talked about this on Tuesday, and then I talked about the normal distribution, which this is the PDF for the probability density function. This is the CDF of the normal distribution, right? And these are R commands. These are R commands for the normal distribution. And now there are tables for reading phi. Phi is the CDF of the standard normal, or in 0, 1. And the table looks something like this. I gave you a copy of this table on the first day of classes, right? And then I gave you certain properties of the normal variable. The first is the expectation is mu, the variance is sigma squared, the standard deviation is sigma. The linear combination of any 2 independent normal variables is also normal. Here A, B, and C are constants. They can be any constants, okay? And the next property I talked about is this one. If you have P independent normal variables, then their linear combination is also a normal variable. Here, AI are constants, right? AI are any constants. And once again, if you have N independent normal variables, then their sample mean is also normal. And finally, this one, which is the standardized transformation. If you have a normal variable, then you can convert that to a standard normal through this transformation, right? I also talked about estimation on Tuesday. That is, if you have a random sample, usually the population is so huge you can't access it. So you have to draw a sample, like heights of 100 people. So you could imagine this as being the heights of 100 selected men in the UK, coming from a population which is normally distributed with these parameters. Because the population is inaccessible, we don't know the exact values of this. We don't know the exact value of mu or sigma squared. So what we can do is we can only estimate them. So these two formulae or formulas give a way of estimating the parameters mu and sigma squared, right? Then I did one example on calculating probabilities, and this is the second example I did on calculating probabilities. Okay, so it's just a reminder of the stuff I did. Okay, now today I'm going to talk about today I'm going to, I know some of you know this already, or many of you know this already. Binomial distribution, right? You say a variable x has the binomial distribution, which I write as follows: if its PMF is, remember PMF stands for probability mass function. When you deal with a discrete variable, is PMF. When you deal with a continuous variable, is PDF. Remember that, okay? Okay, so the PMF is all right, this is the probability mass function of a binomial random variable, right? The CDF, or the cumulative distribution function of a binomial variable, is denoted by this, and is defined as the probability that capital X is less than or equal to little x, right? And is equal to the following. Right? So this is the formula for the CDF of a binomial variable, where once again I'm sure you're familiar with this notation. This notation, I think I mentioned this before, is the largest integer less than or equal to x. Okay. All right, guys. So I put it here. Next one is the R commands for binomial distribution as follows. So the following command so issue this command dbinom in brackets this, right? It will compute right. This command will compute the values of the PMF of this variable binomial with parameters 10 and half at the values specified by x, right? And the following this command here right. So when you say P binom, P binom, it will compute the values of the CDF of this variable at values specified by x, right? Next one. Some properties. I know these are trivial properties for you. So I'm sure all of you know these properties. These are so trivial. I mean, once again, I do not expect you to know the proofs, but if you should know how to prove them, that's great. Okay. Next one is estimation. So suppose you have a random sample from a binomial distribution, right? So once again, this is the population and this is the sample. Remember the distinction between a sample and a population. The population is usually something unknown. So we don't know this, we don't know the exact value of P, right? So we need to be able to estimate. So So I always put a hat on top to mean that it's an estimate of P, right? Okay, is as follows: is okay, I think this is correct. Yeah, so this is the estimate or estimate of P, right? So it's sum the exercise and divide by n times n. Okay. Here, of course, assuming that we know the value for m, right? That is the estimator for P, okay? All right. Now, I want to do a couple of 2 or 3 examples. I have the time. So, example 1. Right, I mean, I'm sure this is too easy for you, right? Now, so to calculate this probability that x is less than 1, because x is a discrete variable, right? If x is less than 1, it must be 0, right? So this is the probability that x equal to 0, and this is 5, choose 0, 0.1 to the power 0, 1 minus 0.1 to the power 5. Okay? So the answer is 0.9 to the power 5. You follow me? Yeah? It's too easy for you, right? Is it not? Yes? Excuse me, sorry, I didn't follow it. 1 over m times n, m multiplied by n. Anybody has a question on this, guys? This is m multiplied by n, right? In the denominator. Times sum of xi. I know it's boring for some of you, but the course will get interesting in a couple of weeks' time. I know, you just be patient with me until then. Is this clear to you, all of you? Yes? No? Come on, guys. Yeah? Are you okay with this? Yeah? Okay. Next, example 2. Right? So in this case, so if this is the same as the probability that x equal to 2, the probability that x equal to 3, plus the probability that x equal to 4 plus the probability that x equal to 5. You with me, guys? Yeah? Talk to me, guys, please. So this you can write as the sum of the probability that x equal to I from 2 to 5. Yeah? And this you can write as 10 choose I, 0.5 to the power I, yeah? 1 minus 0.5 to the power 10 choose I, 10 minus I. So this you can simplify a bit. 0.5 to the power 10. All right. Okay, guys, are you okay with this? Yes? No? Talk to me, guys, please. All right. So this is two trivial examples. I know it's too trivial for all of you. Now, let me give you an example which is not so trivial. So this is example 3. Well, the reason this example is not trivial is because it's hard to compute. So because you can write the probability that you can write this probability as the sum of the probabilities from I equal to 100 to 200, the probability that x equal to I. Okay? Now, this guy here, this will be the same as 100 to 200. This guy here is going to be 1000, choose I, 0.2 I, 0.8, 1000 to the minus I. This is going to be right. This you can't. I mean, you will have a hard time computing this, even with the computer, right? Because you are dealing with very large numbers, like 1000 factorial. You can't compute 1000 factorial in a calculator, right? It's a big number, right? So you can't. So the question is, how do we solve problems like this? All right. How do you solve this problem, guys? So that's what I'm going to talk about now. Okay, how to solve this problem. So this is where the following things comes in. Right? I know some of you might have done this before. So I'm going to use the central limit theorem to solve this problem. Okay? The central limit theorem, I'm sure you know, says the following, right? Suppose all right, suppose you have a random sample from a population with mean mu and variance. So this is the, remember, this is the population mean and this is the population variance, right? Okay? Right, the central limit theorem says the following, that this guy here, x bar is the sample mean minus the population mean divided by this, approaches the standard normal variable as n approaches infinity. So this is known as the central limit theorem, right? Okay. Now, so let me right. Okay, let me use the red pen. This is the sample mean. This is the population mean. And this guy here is known as the standard error. Okay. All right, guys. So the central limit theorem is fundamental to much of statistics and applications, right? Now, what I'm going to talk about here is how to use the central limit theorem to solve this problem, right? N is the sample size. Okay, n is the sample size, right? Now, it says here that as n approaches infinity, this approaches this, right? But in practice, you cannot have infinity. I mean, infinity is something you can't reach. I'm sure all of you know that. Yeah, so n can never be equal to infinity, right? Okay. Okay, so what you can do is you can only choose n so that the distribution of this is approximately equal to this, right? Okay, so This guy here means approximation. Right, so what I'm saying is that you choose n, the sample size, say to be 100 or 1000, whatever you think is large enough, so that the distribution of this is approximately equal to the standard normal distribution. Okay? Come on, guys. Are you still sleeping or what? Some of you? You okay? Yeah. All right. So that's what in statistics, that's what we do, because the sample size can never be equal to infinity, right? So this implies that the probability okay, this guy implies this, right? And this implies that okay. Now, let me call this guy here y, right? I'm just introducing a new notation, right? You know, we are allowed to do that in mathematics. So what this implies is the following. It implies that the probability that x bar is less than equal to y, yeah, is approximately equal to phi. I'm going to replace x by y. So if this guys, listen please, if this is equal to y, what would x be? Huh? Come on, guys. This is not rocket science, right? This is simple question. Yeah, this would be root of n divided by sigma times y minus mu. You follow me? Yeah? Okay. And now, we are not finished yet, because that implies that the probability that, remember, x bar is 1 over n times the sum of xi, I from 1 to n, less than equal to y, is approximately equal to phi of root of n divided by sigma times y minus mu. Okay. Now, I'm going to do some more things, right? So bear with me. So this is going to be, I'm going to take the n here to the right hand side. So this would be the sum of xi less than equal to n times y is approximately equal to okay. All right, now I'm going to do another substitution, guys. I'm going to call this guy here, let me call this guy z, right, or z, or whatever, okay? So this guy will become sum of xi less than equal to z, right, is approximately equal to phi root of n. Now, if this is equal to z, guys, y will be what? y will be z divided by n. You with me? So this is the result I wanted. So the result I wanted is this one. Now, I'm going to show you, if I have time, maybe not, but I'm going to show you that this result here can be used. The result I have written over here can be used to solve the problem that we had, which is this one here. See? The result over here can be used to compute this probability that x is between 100 and 200. I think I don't have the time for that. I will talk about it. I will talk about the use of this result when I see you guys next week on Tuesday, right? But before that, if you haven't been to the lab sessions, please do go to the ones today or tomorrow. I will bring you a chocolate, free chocolate for all of you. Okay? Same way, 0.5